So let's get into the triangle part of trigonometry. So we're going to look at those 6 basic trigonometric functions and how to solve right triangles. Hopefully review. Trigonometry, we're going to find unknown angles and sides using unique properties of triangles. Trigon comes from means triangle. Metry is the part of the word that means measure. Alright, so quick overview here. Similar triangles have proportional side lengths. All right triangles with angle theta are, so if each one of these triangles has this angle A, let's say that's theta, then these other angles are all going to be congruent because 90 minus theta, I do that each time, and so I'm going to get the same number each time. All of these angles are going to be similar, or all these triangles are going to be similar. So if all of the triangles are similar, all of their side lengths are in proportions. So all of the ratios that exist in the smallest possible triangle I can make with angle theta will exist in every other similar triangle. So there's a bunch of ratios that we could write, but we have some common ones which we call sine, cosine, and tangent, and then we have their reciprocals. Sine we call, alright, so let's make our little theta here. Okay, so if theta is down there at angle A, sine is the opposite side over the hypotenuse. Actually, let me use the colors already there. Alright, so sine, and then cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And then cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, cotangent is adjacent over opposite. 6 trigonometric values. Let's just go ahead and copy these down real quick. You could probably write them faster than I can, but I'm going to pause and cheat. So there's 3. I didn't need to reduce them. I just put them into their fraction form. And then the other 3 are the reciprocals of those. And there you have it. There's the 6 basic trigonometric functions for angle D. Your turn. You find the 6 trigonometric functions of angle E. To solve a right triangle, you need to find all 3 angles, all 3 sides. However, in order for you to solve, you need at least the fact that it's a right triangle, so that's one angle, and you need 2 other pieces of information. You would need another side, 2 other sides, or a side and an angle. If you're given 2 other angles, you can't really figure it out. You need at least one side. Okay, let's solve this right triangle here. We have 8, 10, and then we don't know the hypotenuse, so I'm going to go ahead and use the Pythagorean theorem. 8 squared plus 10 squared equals b squared. Hate it when they put b or something else as the hypotenuse. So we have 64 plus 100, that's 164, and the square root of that is 12.8. Okay, but what to do about those angles? That's where we use the word inverse. So angle A, let's say, okay, I'm going to solve for angle A, so I'm going to quickly label opposite adjacent hypotenuse, and then I'm going to use that information to set up a trig ratio. Let's use sine. So let's say the sine of A is equal to 10 over 12.8. And so I'm going to figure out, alright, so the sine of A, 10 divided by 12.8, is equal to 0.7813. I'm going out 4 decimal places, please do that. And then I'm going to take the inverse sine of both sides, so that I get angle A is equal to the inverse sine of 0.7813. And we get 51.38. We can round the final one to a tenth there if we want. So let's do 51.4 here. Well, do I have to repeat that process for C? No, I can actually just subtract that from 90. So let's do 90 minus 51.4, and we get 38.6 degrees over here. So side B was 12.8, angle A 51.4, angle C 38.6. So this one we're starting off, we know a side and an angle. We're going to solve for the two sides. This is probably the ones you solved more often in geometry. All right, I'm given angle R, and I know that's 20 degrees. I'm going to start off by solving for side R. All right, so let's do sine. Well, we have to. So I'm going to do the sine of 20 degrees is equal to R over 15. I don't know what it is yet, but I want to get R by itself. So clear the fraction. So I'm going to pop that into a calculator. 20, take the sine of that, times 15 equals 5.1 for R. And then I can either use the Pythagorean theorem to find S, or I can use trig. I'm going to do trig again. I'm going to take the cosine this time because S is adjacent and we have 15 as the hypotenuse. Clear the fraction. And I'm going to take the cosine of 20 times 15 equals 14.1. And then to find angle S, that one's easy. Just subtract from 90, and we're left with 70 degrees. Okay, so cosecant is the reciprocal of sine. So this is 1 over the sine of 82. So we're going to do 1 divided by the sine of 82. And we get really close to 1 here. It's just about 1. We're going to do 1 over cosine of 82 to get the secant. And we get approximately 7.2. I guess I should go out to 4 decimal places. 7.1853. And the last one with cotangent, that's the inverse of tangent, so 1 over tangent of 82. And that's approximately 0.1405. Hopefully your calculator's been in degrees this whole time so that you are getting correct answers. Okay, solve on your own to figure out. We need side BC, or we could call that side A. We need side C, and we need angle B up here.